Today we're going to talk about noise-induced hearing loss. We're exposed to noise every day in our environment. Most of these sounds are safe to listen to and won't cause any damage at all to hearing. In fact, they're an important part of everyday life. But when sounds are too loud, or both too loud and long-lasting, then there's potential for damage. It's nothing new for people to experience a loss of hearing due to excessive noise, but our understanding of the issue has increased considerably in recent years. Maybe it's apt that this video comes from Manchester. It's considered the home of the Industrial Revolution, with the boom to the textiles industry from the mid-1700s. This industry meant that becoming deafened due to excessive noise was a common hazard of the job. Had we have had the awareness, understanding and desire to prevent this, it would have ensured a better quality of life for many people. It's important to remember that the effects of noise damage aren't just limited to factory workers. In reality, there are many occupations and activities which might contribute to noise-induced hearing loss. From road workers, to those who work in the music industry, to even common activities such as listening to music through headphones, which for some people all over the world is damaging their hearing without them even realising the implications of their actions. So what we might wonder here is, what level of noise is hazardous? Now, there are two main factors in understanding whether noise exposure could be hazardous to hearing health. Those two factors are the length of time that you're exposed to noise and the volume of the noise. We're able to measure sound pressure level using a sound level meter. Although these sound level meters might not be available to most people, there's now also an opportunity to measure sound pressure level using a variety of mobile phone applications. Some of these apps give enough reliability for use if the intention is just to understand how loud a sound is in a setting. This diagram shows a range of sounds, such as very loud sounds like jet engines and pneumatic drills, all the way down to the quietest sounds that we can hear. Now, the World Health Organization recommends a daily exposure limit, and loud sounds such as pneumatic drills are safe for less than only a matter of seconds without ear protection. But other sounds such as rock concerts may also create a similar effect if the exposure is experienced for longer. Beginning to think about how noise-induced hearing loss occurs. To understand this, we need to think back to how we hear. You'll remember in week 1 that we talked about the ear and how this works. We know that sound waves enter the outer ear and travel through the ear canal, which leads to the eardrum. The eardrum vibrates from the incoming sound waves and sends these vibrations to the 3 tiny bones in the middle ear. The bones in the middle ear push on the oval window of the cochlea, moving the sound vibrations from the air through to fluid vibrations in the cochlea, which is shaped like a snail and filled with fluid. As we look inside the cochlea, running from the beginning to the end is the basilar membrane. And on top of that membrane lie the hair cells. When the middle ear bones push onto the oval window of the cochlea, this transducts the sound through this fluid-filled chamber. This enables the hair cells to move up and down with sound, and the microscopic hair-like projections on top of the hair cells bend and open up. These hair-like projections are called stereocilia. When that happens, chemicals rush into the cell, creating an electrical signal. The auditory nerve carries this electrical signal to the brain, which translates it into a sound that we can recognise. Now, for many day-to-day sounds, this works just fine. This process happens without us even knowing it and enables the sensation of hearing. But where the sound is too loud, this causes damage to the hair cells, which, as you might remember from the video in week 1, are tonotopic, meaning that they're arranged according to frequency. Those in the basal coil of the cochlea are most sensitive to noise damage and are responsible for transducing the higher frequencies. This accounts for the high frequency loss that's found in people who have noise-induced hearing loss. If we can appreciate the importance of hearing sounds such as s, sh, and t, which are high frequency, then we should be able to understand the implication of noise-induced hearing loss and speech perception. If we take those sounds out of running speech, it can be very difficult to understand. Noise-induced hearing loss can be classified into 3 categories. Let's take those 3 categories in turn and think about how this works. If we consider a temporary threshold shift, this is the elevation of threshold of hearing, which recovers gradually following noise exposure. It can vary in sensitivity from just a few decibels to rendering the ear temporarily deaf. After the noise has stopped, hearing sensitivity can return to pre-exposure levels if the noise is ceased and not repeated. In terms of permanent threshold shift, industrial workers who've been exposed repeatedly to high-intensity noise for a relatively long period of employment might experience this. It tends to occur first for high-pitched sounds, so the volume of sound may be unchanged, but its quality lessens. This affects speech perception considerably, and therefore has a large and lasting impact on the individual. At the moment, this is irreversible and cannot be repaired. And if we consider the 3rd classification here, acoustic trauma, this considers single exposure or a few exposures to a very high level of sound, such as an explosion or gunfire. This might be an immediate permanent hearing loss, again, one which cannot be repaired. So who is susceptible to noise-induced hearing loss? So now we're going to start to think about who is vulnerable to this type of hearing loss and how common this is. Let's consider this chart a little further. If we take corn milling, which is discussed by the book chapter, a study of a corn mill in Ghana showed the noise levels exceeded 90 dBA, with locally made corn mills producing more noise than imported equipment. And here, looking at the formal sector, if we consider to look at what typical noise levels might look like, it's worth considering this, which highlights the noise levels emitted from a range of equipment in industrial plants in Pakistan. It's little surprise considering this that a report from the World Health Organization in 1997 discusses the problem of widespread and increasing excessive noise exposure and its particular relevance to developing countries. Whilst this report is old now, it's still just as valid, with a number of recent papers still highlighting the issues involved. As we can see here, a study of shipbuilders in Goa in India. This study showed higher prevalence of noise-induced hearing loss for shipbuilders compared to those working in non-noisy environments. Interestingly here, those with this type of hearing loss were not using earplugs consistently. And here, a study from 2005 in a steel rolling mill in Nigeria. Now, the participants in this study had a high awareness of the hazard of noise to hearing. For example, 93% of people knew that this was a risk, but only 27% of the workers had hearing protection, and unfortunately, only 28% of them used it all the time. And here, a different study identifying the difficulty of increased use of personal music players in Pakistan. Now thinking about ways to prevent noise-induced hearing loss. If we have enough awareness and understanding, then some of the changes required can be achieved even at a modest cost. Pretty much this type of hearing loss is preventable, and clearly the availability of ear protection, the understanding of the need and use and appropriate use, regulations which protect the hearing health of employees, and insistence from employers that employees conform to regulations is key. There's also a range of low-cost methods of noise reduction which can supplement this use of hearing protection, such as the location of equipment. It's suggested that carefully planning the workplace can enable noisy areas to be located away from quiet areas, such as using storerooms and holding areas as buffer zones. Selection of quieter machines and quiet processes. By carefully selecting equipment, noise can be greatly reduced. Noise data on machines can be provided from vendors, and this would be a starting point to predicting the noise level. Installation of absorption materials. By replacing hard, smooth surfaces with rough, soft and absorbent materials, sound can be absorbed. Maintenance of machines. Proper maintenance of machines can help to reduce increased noise or vibration. Rotation of jobs. Job rotation can be used to ensure that workers swap between noisy and quiet tasks. Although it's recognised that this might be difficult to implement for a variety of reasons, including labour skills, wages, and even worker resistance. I hope you've enjoyed learning about this entirely preventable cause of hearing loss, and that you'll be able to bear reference to this in the discussion board later this week.